Hello everybody, hope you're doing okay. In today's session we'll be answering Bsc Pharmacy Test 1. So let's get right to it. So the first question reads, give systematic IUPAC names for each of the following. So let's look at our first compound. I have already highlighted in red the parent chain. So after looking at this, now the question someone would ask is, which side do I count from? Do I count 1, 2, 3? Or do I count 1, 2, 3? So the best way to count, you count in such a way that the loci, meaning the position, with many substituents should get the smallest number. So if I counted from this side, 1, 2, 3, the loci with many positions would get 4, which is wrong. So I need to make sure 1, 2, 3, right? And then after doing that, the rest becomes easy. So what are the attachments? I have 3 methyl groups. So the first methyl group is at position 3, right? Comma. The second methyl group is at position 3. And the last methyl group is at position 4. 1, 2, 3, 4. 4 there, right? And then you should know that whenever you're separating numbers, you use a comma according to IUPAC rules. And then whenever you separate a number and a letter, you use a hyphen. So this would be 3, 3, 4, and then because there are 3, I'll say tri methyl 3, 3, 4 tri methyl, and then our parent name. So our parent name will be 1, 2, 3, 4, 5, 6 tri methyl hexane. So that will be the name of this compound. Let's go to the next one. When we look at the next compound, when we identify the parent chain will look like this. So after identifying the parent chain, you're able to see that there are 2 attachments, 2 methyl groups at position what? Position 2, relative to this hydroxyl group. So this will be position 1, 2, 3, and position 4, right? So how do I name this compound? I say at position 2, there's a methyl group. And also at position 2, there are 2 methyl groups, right? And then I use the hyphen. And then this time, instead of saying tri, I'll say dimethyl. So I'll say dimethyl. And then what's the parent? 1, 2, 3, 4. Butanol. Right? Because we have an alcohol. Someone could have said butane 1O. That would have also been fine if you say butane 1O. It's also another way. So we could say 2, 2 dimethyl butane 1O. Reason, because the alcohol group is at position 1. So let's go to the next one. So when we look at the next one, this one looks long, but it's actually quite easy. So the parent chain looks like this. So after identifying the parent chain, we're able to see that there are only 3 attachments here, right? And regardless of which side I count, the attachments will still be on the same position. So if I count 1, 2, 3, 4, 5, 6, 7, right? At 3, 5, and 7, right? 1, 2, 3, 4, 5, 6. So regardless of whichever side you count from, you'll get the same exact answer. So I'll count from this side. 1, 2, 3, 4, 5, 6, 7, right? So which attachments do I have? I have methyl groups. So I'll say at position 3 there's a methyl group, at position 5 there's a methyl group, and at position 7 there's a methyl group. Because I've listed 3 methyl groups, I need to use the prefix tri. So I'll say tri methyl or trimethyl, and then the parent chain 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is nonane. The next one, identify the parent chain. The parent chain is this. So after identifying the parent chain, what do we do? So let's try to figure this one out. So do we count from the right to the left, or from the left to the right? So if we counted 1, 2, 3, 4, 1, 2, 3, 4, the alcohol is at position 4 regardless of whichever side you count from. And then we know the alcohol group has more priority in this molecule. So which side is the best side to count from? So you count in such a way that the substituent attached should have a small loci. Therefore, we count from this side, so that it can have the loci 3. So how do we name it? We'll say 1, 2, 3. So we'll say 3. What functional group is this? It's a methyl group. Hyphen 3-methyl. Right? So we'll say 3-methyl. And then what other attachment? We don't have any other attachment, but we say 1, 2, 3, 4. At position 4, there's this hydroxyl group. So what do we say? 1, 2, 3, 4, 5, 6, 7. Right? So 7 is heptane, right? So I could say heptane. And then at position 1, 2, 3, 4. Position 4, there is an alcohol group. Right? And then you've named that compound. So now let's look at the next question. So when we look at the next question, we have this situation where you have 2 rings. So this one might look complicated when you start working it out, but it's actually very, very simple. So all you need to know is that when you have 2 rings, find the parent chain. The first step is still the same, right? How do you know which one is the parent chain? Whenever you have a system of rings, the parent chain will always be the chain that either 1 has more carbons or 2 has a dominant functional group, either one of the 2 options. So because there are no functional groups attached, I'll look for the one with more carbons. So therefore this will be the parent chain. So this will be the parent chain. So if that's the parent chain, I could start counting, saying 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? So if I counted like that, how do we name this compound? I could say at position 1 there is an attachment. What's that attachment? That attachment is a cyclic attachment. So at position 1, so I'll say at position 1 there's an attachment. What's the attachment? We have a cyclobutyl attachment. So 1 cyclobutyl, right? And then what's the parent chain? Cyclopentane. Therefore you've named the compound. So we say 1 cyclobutyl cyclopentane. And then let's go to F. Parent chain, it's as easy as that. Let's see, which side can we count from? 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. We make sure the functional group should get the lowest possible loci. Therefore, it's logical to count from this side. So we'll say 1, 2, 3, 4, 5, 6, 7, 8. If we do that at position 2, 3, 4, 5, and at position 5, they are bromine functional groups. And then at position 1, 2, 3, 4, position 4, so this is 2, 3, 4, 5. Alright, so how do we go about naming this compound? You need to consider alphabetical order. So because you have 2 functional groups, a bromine group, and then you also have an ethyl group. So you ask yourself, what comes first in the alphabet between B or E? Everyone knows that B comes first. So therefore you mention the bromines first. So at position 2, there's a bromine. And also at position 5, there's a bromine, right? So I'll say dimethyl. What else can I see? I see an ethyl group, and it's at position 4. So I'll say 4 ethyl. And then I talk about my parent chain. So 1, 2, 3, 4, 5, 6, 7, 8. So the 8 is octane. So having done that, that's section A.